Good afternoon, class. Here's pre-calculus practice number 2, module 2, covering chapters 3 and 4. Chapter 3, polynomial rational functions. Chapter 4, exponential and logarithmic functions. And here's chapter 3, polynomial and rational functions. The price demand function of a company that manufactures vats, a large tank or top used to hold liquid is given as P of x equals minus 5x plus 600. Find the revenue function. The revenue function by definition is the number of units sold times the price function. So the product of x and P of x. So all you have to do, multiply this by x, the number of units sold. Negative 5x squared plus 600x. The company's fixed monthly cost is $1,563, and each unit of VATs costs $10. Write the cost function C of x, where x represents the number of packets produced. Well, the cost, there is a fixed cost, and $10 per unit, so 10 times x plus 1563. Find the profit function. By definition, profit function is revenue minus cost. So we are going to subtract the cost from revenue. So we are going to write the revenue function minus 5x squared plus 600x. We are going to distribute the negative sign, minus 10x minus 1563, or 1563. These two are like terms. They result in 590x. The rest remain unchanged. How many bets must be produced and sold in order to maximize profit? It's a quadratic function, QF, where a is negative 5, it opens down. The maximum occurs at its vertex, x equals minus b over 2a. So minus, here's b, because remember, ax squared plus bx plus c. That's the standard form of writing a quadratic function. So a is negative 5, b is 590. So the vertex occurs at x equals minus b over 2. So minus 590, 2 times negative 5, and we get 59. What is the maximum profit? We plug in to the profit function, and we evaluate it. So minus 559 squared plus 590 times 59 minus 1563 gives us $15,842. What price must the company charge in order to maximize profit? We go back to the price function. We decided the number of units should be 59. We are going to replace the x. Minus 5 times 59 plus 600 is $305. So that would be the price that we charge per unit to maximize profit. The polynomial of degree 3, P of x, has a root of multiplicity 1 at x equals negative 6, and a root of multiplicity 2 at x equals 4. P of x passes through the point 2, 8. Find a formula for P of X in factored form? Well, this indicates there is a factor of X plus 6. The multiplicity is 1, that means the exponent is 1. This gives us X minus 4. With multiplicity 2, the exponent is 2. So we write P of X is a some number, some leading coefficient that we don't have yet. This gives us X plus 6 because the multiplicity is 1. The exponent is 1. We don't have to write it. This results in X minus 4 because the multiplicity is 2. We must write. Everything is in order. Now we have a pair 2 comma 8, which means if we replace the X with 2, the Y or P of X must be 8. That will help us find 8. Let's plug it. 2 comma 8, which means P of 2. It's 8 times 2 plus 6 times 2 minus 4 squared. 2 plus 6 is 8. 2 minus 4 is negative 2. Quantity squared. And so here's what we get. You can just drop the 8. So 4a is 1. A is 1/4. So P of X is 1/4 times X plus 6 times X minus 4 quantity squared. So to give you an idea of what's going on, polynomial of degree must have 3 roots. Total number of roots, complex roots are 3, n. One of them is given as x equals negative 6. That means the factor of interest is x plus 6. One of them is x equals 4. So the factor of interest x minus 4. This one has multiplicity 1. That means to the power of 1 we don't write. Multiplicity 2, that means it's being multiplied by itself 2 times. One pair will help us find the leading coefficient A. Divide using synthetic division, express the answer as f of x over d of x equals q of x plus r of x over d of x. So we are going to divide 3x cubed minus 2x squared plus x minus 4 by x plus b. As far as the synthetic division goes, you must write the coefficients, and I hope everybody remembers long division from before. You write the coefficients in order: 3, negative 2, positive 1, negative 4. If anything is missing, for example, this one is missing, you need to have a 0 as a placeholder. Division by x plus 1, you put negative 1 in there. If it's x minus 1, you put positive 1. If it's x plus 5, you put minus 5. Okay? So in general, in some text, they call this x minus c, then they use c. In some text, they use x minus a, they use a. In some text, they say x minus k, they use k. So I hope everybody is clear. So the way it works for synthetic division, this number, you just drop it. Then you multiply this by this number. So let me put this one. So you're going to multiply this by negative 1. You get negative 3. You add this 2. You get negative 5. Again, you multiply by negative 1. You get positive 5. You add this 2. You get positive 6. You multiply by -1 again. You get -6. Add them up, you get -10. If you look at the degree here is 3. The degree here is 1. So the difference between the two is 2. So this one is 3x squared. So again, how do you figure out the variable and its exponent? First of all, you're using x, so the variable is x. Secondly, if you divide the first one by the first one, you get x squared. That's the idea. So 3x squared minus 5x plus 6, and this is the remainder. So this is the remainder, everybody. Or, so here's how they want us to write in this format. 3x cubed minus 2x squared plus x minus 4 over x plus 1 is 3x squared minus 5x plus 6 plus -10 over x plus 1. You can write plus with minus here, we just put a negative sign here. Either way is fine. Consider the function f of x equals 2x cubed minus 8x squared plus 5x plus 3. List all the possible rational zeros of f. So what is rational zeros theorem? Rational zeros theorem indicates if you have a polynomial in the following manner, f of x equals a sub n, x to the power of n all the way to a sub 0, possible rational zeros are factors of a sub 0, the constant, over factors of a sub n, the leading coefficient. So for this one, this is a sub 0. This one is a sub n, more specifically a sub 3 because n is 3, okay? So factors of a sub 0 over a sub n would be factors of 3 over factors of 2. Okay, I'll make sure we understand. So a sub 0 is the constant. A sub n, even n is 3, is equal to 2. The reason n is 3, because this is of degree 3. Now, what are factors of 3 plus minus 1, plus minus 2, plus minus 3? Let me write this for you. So the numerator has the values plus minus 1, plus minus 2, plus minus 3. The denominator has plus minus 1, factors of 2, plus minus 2. So if you divide this by the plus minus 1, you get the same as the numerator. If you divide this one by this one, you get plus minus 2. By this one, you get plus minus 3. By this one, you get plus minus 3 halves. And these are all possible zeros, which means if this is supposed to have a rational zero, can't be any other number. So if that's the case, you can do the synthetic division or divide the factor theorem, okay, to find out which one of them produces a remainder that is 0. So you can plug it into this. F of -1/2, f of +1/2, f of -1, f of +1, f of -3 halves, +3 halves, -3, +3, all of the above. Now, I'm not going to go through all of them, but that's the process. It so happened, if we plug in 3, so find the rational zeros. That's the reason we come up with those, we want to come up with the rational zeros. So if we do f of 3, which is 2 times 3 cubed minus 8 times 3 squared plus 5 times 3 plus 3. This is 27, 54, 9, minus 72 plus 15 plus 3, we end up with 0, which means 3 is a rational 0. And because this is degree 3 plus, 1 is good enough, because if 3 is a 0, that means this function is divisible by x minus 3. So if we divide by x minus 3, becomes of degree 2, and then we can either factor it or use the quadratic formula to find the rest of it. So to do so, we are going to divide the function by x minus 3. Find the remaining zeros of f. The process is to divide by this and figure out what happens. On division, it's easy. We are going to use the synthetic division. We're going to go with 2, negative 8, 5, 3. And over here, x minus 3, we're going to put 3 there. Remember the first. So again, 2, negative 8, positive 5, positive 3. Division by x minus 3, we put the 3 here. So we drop the 2. We multiply 2 by 3, becomes 6. We add these 2. We get negative 2. Multiply by 3. We get negative 6. With 5, they add up to negative 1. Let me just do this so you can remember this. So you're going to add these 2 now. So we get negative 1. You multiply by 3 and you put it here. And when you add these 2, you get 0 as expected. And now, because the degree here is 3 and the degree is 1, this has degree 2. So 2x squared minus 2x minus 1, remainder is 0. And this is a quadratic expression. We can use factoring. Since it can't be done, we use the quadratic formula on that. So to use the quadratic formula, ax squared plus bx plus c equal to 0, x is minus b plus minus a squared of b squared minus 4 is. A is 2, b is negative 2, c is negative 1, plug in. So minus b minus negative 2 plus minus a squared of b squared negative 2 quantity squared minus 4 ac, 2 times negative 1 over 2. And so this is 4, everybody. So this is 4, and this is plus 8, or it makes it 12. 12 is 4 times 3. So we have 2 square root of 3, and we can factor the 2 out from the top. The 2 drops, and we get 1 plus minus square root of 3. Now factor f of x using the zeros of f. So simply put, this is x minus 3. This is x minus that. There are 2 answers here. So let me write it in that format so you can see that. So one of them is 1 minus square root of 3. The other one is 1 plus square root of 3. So x minus the first one, and then x minus the last one. In other words, f of x becomes x minus 3, x minus the parenthesis 1 minus square root of 3, x minus the parenthesis 1 plus square root of 3, and we multiply all those 3 factors. So a quick recap. How do you list possible rational zeros? You write all factors of the constant a sub 0. You can list all factors of the leading coefficient. and the ratio would be possibility, and you have to evaluate the function at any of those, and eventually when you hit the zero, that's the one that is a rational zero. And by the way, in this case, we don't have any more rational zeros. In some case, all of them are rational zeros. You can continue working on them or still um, figure out the rest with the quadratic function. All right, so in this case, consider the function f of x equals x to the power of 4 plus 2x cubed plus 22x squared plus 50x minus 75. We want to find f of 1 and f of negative 3, which simply means plug in 1. So obviously, this is 1. See, this is 1 cubed, this 2 times 1. This is 1, this is 1. So all of them are 1 times 2. This is plus 22 plus 50 minus 75. This is 0 class. Now for f of negative 3, I leave it for you to evaluate it, becomes the same thing. The idea is that you say, let me use a different color, minus 3 to the power of 4 plus 2 times minus 3 cubed all the way to the end. And you show that that is also 0. What if we were to use rational zeros? What if they weren't given to us? Then we would have to write factors of negative 75 over factors of 1. Please understand, since this is a sub 0, this is number 1. So a sub n is a sub 4 equals 1. Why a sub 4? Because the degree is 4. And so factors of 1 is plus minus 1, just factors of minus 75, that's plus minus 1, plus minus 3, plus minus 5, plus minus 15, 25, 75, so many, okay? And since this is degree 4, and we already have 2 of them, if nothing is given to us, we can multiply x minus 1 and x plus 3, divide this one by it, and find the rest. We can do that. But that's not what we want to do here. As far as technology is concerned, you can graph second calculator 0 or try these numbers one by one. You can plug in and you see that they give you 0. If 5i is a 0 of the function, if we know that 5i is a 0 of the function, find the remaining zeros of f. This is of degree 4, and it has 4 zeros, okay? We already have 2 of them, and now the third one, so there's only one more left. So, conjugate zero theorem. If P of x is a polynomial with real coefficients, and if R equals A plus BI is a 0 of P of x, then the conjugate R bar A minus BI is also a 0 of P of x. So if A minus B, if A plus BI is a root, is a 0, so is A minus BI. So 5i, its conjugate is negative 5. And now factor f of x using zeros of f. So we're going to write f of x is equal to, so we have this one x minus 1, this one x plus 3, this one x minus 5i, this one x plus 5i. And it's important to know this is x squared plus 5 squared. I hope you remember a minus bi, a plus bi is a squared plus b squared. So we have x minus 1, x plus 3 times x squared plus 25. This is how you write the factored form, you can't leave it like that with the complex number. Find the domain of the following. Express your answer in interval notation. Well, whenever you have a rational expression, you set the denominator equal to 0, you exclude it, that becomes its domain. We want two numbers, the product is -8 and the sum is -2, +2, -4. So x is either -2 or 4. These are the numbers that make the denominator 0. So what is the domain? Domain, you can say x is not -2, x is not 4. That's one way to write it. That's not how we want to do that. We want to do it with the interval notation. So how do you write that? Basically, from negative to positive infinity, how do you exclude those two numbers? Negative infinity to -2, parentheses u, union, parentheses -2, 4 parentheses, union 4, infinity, everything takes parentheses. That's how you're excluding the endpoints -2 and 4. As always, the negative and positive infinity, they will always take parentheses. Use the remainder theorem to evaluate f of x equals 6x to the power of 4 minus x cubed minus 15x squared plus 2x minus 7 at x equals 2. The remainder theorem basically says plug in, okay? And whatever the value is, that's the remainder. So let's plug in. 6 times 2 to the power of 4 minus 2 cubed minus 15 times 2 squared plus 2 times 2 minus 7. 2 to the power of 4 is 16, 2 to the power of 3 is 8, 2 squared is 4. This gives us 96, this is -8. This gives us minus 60 plus 4 minus 7. And they add up to 25. Now, if the remainder is 0, it becomes the concept of a factor theorem. So you plug in, it gives you a number. That's a factor theorem. That means if you divide f of x, if you divide f of x by x minus 2, this is the remainder. Now, if this happened to be 0, then it makes x minus 2 a factor of f of x. That is known as a factor theorem. Show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Find the remaining factors. Use the factors to determine the zeros of the polynomial. To show this is a factor, we have one easy way is to evaluate this. Let's call this f of x and evaluate it at -2. Remember, division by x plus 2, you evaluate it at -2. So we are going to say this is f of x. So you want to find f of negative 2. So negative 2 quantity cubed minus 6 times negative squared minus minus 2 plus 30. So this is negative 8. This is positive 4 with negative 6. The product is negative 24 plus 4 plus 30. My plus 2. Okay. And they add up to 0 because this is negative 32, this is positive 32. And that's a proof, which means if I want to find the rest of the factors, I can divide this one by this one, and the remainder is 0, so I'm going to use the synthetic division. So I'm going to write 1, negative 6, negative 130, and I'm going to divide by negative 2. So 1 drops, then multiplied by negative 2, negative 2. They add up to negative 8, and so on. So take a look at what happens. 1 drops, just you multiply this one. You always multiply by negative 2, you get negative 2. Is to add up to negative 8. You multiply by negative 2, you get 16. This to add up to 15, you multiply by negative 2, you get negative 30, add up to 0. And therefore, you are going to write that this function or this expression is the product of this and 1x squared, or simply x squared, minus 8x plus 50. Now, this is an easy factoring because we want two numbers. The product is 15. The sum is negative 8, negative 3, and negative 5. So therefore, as far as the zeros are concerned, we have negative 2, positive 3, positive 5. Let's switch gears. Let's look at a rational function and its graph. Given this function, f of x is x plus 4 over 2x squared plus 11x plus 12, find the domain of f in interval notation, and there are other steps. So remember, to find the domain, you set the denominator equal to 0. So to do so, let's factor the denominator if it's possible. 2 is a prime number, and you can work with that. It's x and 2x. And then 12 is simply 1 times 12, 2 times 6, 3 times 4. The trial and error gives you x plus 4 times 2x plus 3. So the domain would be all real numbers except what makes this one 0, which is negative 4, what makes this one 0, which is negative 3 halves. And by the way, the function is equal to this one because you can drop the common factor of x plus 4 from the top and the bottom. However, this graph still has the missing number here. X can't be negative 4. So when you graph rational functions, if there is a common factor between the top and the bottom, that common factor will be dropped, will not give us a vertical asymptote. However, it will create a hole. So one more time. When we want to find the vertical asymptotes, we set the denominator equal to 0. However, we would set the denominator of a fraction which is in its lowest term, not this one. So if there is a common factor, that doesn't make x equals -4 a vertical asymptote, rather it makes it out. In any way, the domain doesn't change anyways. -4 can't be there, -3/2 can't be there. So we write from -∞ to -4, union -4 to -3/2, union -3/2 to infinity. This is the way we represent an interval notation for the domain. Find the asymptotes of f of x as well as any holes. The holes I've mentioned already. You factor completely. If there is any common factor, you drop it, and it creates a hole at x equals -4. And how do you find that hole? You have to put it now into the simplified version to figure out what that hole is. So if you plug in here, you get 1/2 times -4 plus 3. This is -8 and 3. It's -5, so 1/-5. This is the location of a hole, everybody. So 4 to the left, 1/5 down, and we get this may not be to scale, roughly there that there's a hole there. Vertical asymptotes, you set the denominator equal to 0, not this denominator, the simplified version. To find any vertical asymptote, you set the denominator equal to 0. 2x plus 3 is 0. X equals -3/2. What about horizontal asymptotes, slant asymptotes? Here's how things work. So that's your vertical asymptote. X equals -3/2. Now, given a rational function, so I want to remind you how we learned the asymptotes in previous courses. I already explained the vertical asymptote, set the denominator equal to 0. That's all. Of course, not this one. It's simplified. If f of x is n of x over d of x, n is the numerator a sub n x to the power of n to a sub 0. D of x is the denominator b sub m x to the power of m to b sub 0. If n is less than m, that means the degree of the numerator is less than the degree of the denominator. The horizontal asymptote is the x-axis, which has the equation y equals 0. If n is equal to m, then the concept of asymptote is what happens in a long run. In a long run, everything becomes small compared to these two. So the leading terms take over. Since they have the same degree, they cancel each other, becomes a sub n over b sub n. If the numerator has a degree which is larger than the denominator by precisely 1, then we could use long division or synthetic division to come up with the answer. Because the difference is only 1, the answer is a linear function. Okay. The quotient is a linear function, and then remainder, okay, is just a number. Then this piece, y equals this piece, y equals mxp, is called the slant or oblique asymptote. Now, the degree of the numerator is 0, the degree of the denominator is 1, so we are right here, y equals 0, and there is no oblique asymptote. OA, see, VA vertical asymptotes, HA horizontal asymptotes, OA or SA. OA is oblique asymptote or a slant asymptote. So here's the line, the x-axis or y-coordinate. Find the intercepts. Well, to find the intercepts, x is 0, find y is 0, find x. So x-intercept, you set y equal to 0, and there is none. Why not? Because if you set f of x or y equal to 0, you have to, a fraction is 0 when the numerator is 0. And whenever the numerator is a number, it can never be 0. Therefore, there is no x-intercept. Y-intercept, you set x equal to 0. If this is 0, you get 1/3. So 0, 1/3. So x-intercept, we don't have any. Again, because the numerator is a number. Y-intercept, replace the x with 0, you get 1/3. And you locate that somewhere there. This is the y-axis, this is the x-axis. Locate at least one point on each side near the vertical asymptotes. When you want to graph a rational function, and we are saying a function, okay, then you look at the vertical asymptotes, and all you need is a point on each side, really, because this is your horizontal asymptote class. So it either goes like that, or this, or like that. And also it may cross the horizontal asymptote. We already know that doesn't exist because we said x, there is no x-intercept, right? Because you have to set this equal to the horizontal asymptote. So you have to set this equal to 0. There is nothing in common. So if you pick a point to the right and to the left side, for example, we said the vertical asymptote is -3/2. Let's go with -2. And the right side, let's go with -1. And see what we get. So if I put -2 here instead of x, I get -4 and 3 is -1. And -2 comma -1. If I put -1 here, this becomes 1, I get 1. So those are the two pairs. Again, plug in -2, you get -1. Plug in -1, you get +1. So those are the 2 points. And clearly the graph is this one and this one. Sketch the graph, label the intercepts, asymptotes. So these are the graphs, okay? And of course, this is the whole as it was mentioned. -4, -1/5. The vertical asymptotes, x equals -3/2. The horizontal asymptotes, y equals 0. And the rest of this stuff. Given the function f of x equals x plus 1 times x minus 5 over x minus 3, find the domain of f in interval notation and so forth. We want to do the same thing. Ultimately, we are interested in graphing this rational function. So we're going to go through the process. And to find the domain, basically, you set the denominator equal to 0, x becomes 3. And so you exclude that. Everything except 3. -∞ to 3, union 3 to infinity. Find the asymptotes of f of x as well as any holes. Well, there is no hole. Why? Because this is a factored format, there is nothing in common. So there is no hole. Vertical asymptote, the denominator is 0. X equals 3. Horizontal asymptote, there is none. Because if you look at the degree of the numerator, you notice is x squared, or you can write x squared minus, this is minus 5, this is plus 1, minus 4x minus 5. The degree of the numerator is larger, so that is x equals 3, your vertical asymptote. And so this one indicates the degree is larger. You don't have horizontal asymptote. But you have oblique asymptote, and you have to do the division. So you do the division, either long division or synthetic division, and I'm going to leave it for you to do that. It's very straightforward. You get x minus 1 minus 8 over x minus 3. So y equals x minus 1 is the oblique asymptote. And as I mentioned, there is no hole. The reason why is because there is nothing in common between the numerator and the denominator. So you can graph that. This is the line. So just to give you an idea, 0, negative 1 is roughly here. 1, 0 is roughly here. And that's the line y equals x minus 1. Find the intercepts. Well, x is 0 is fine. Y is 0, find x. So if y is 0, from here you can see negative 1, 0, and 5, 0. So those are easy, okay? So f of x equals n over d, n equal to 0, that gives you the x-intercepts. Now the y-intercept, you replace the x with 0. It's easier to do it here. If you do that, you get 0 minus 5, which is minus 5, 0 minus 3, which is minus 3. So minus 5 over minus 3. So y-intercept is 0. So those are the two x-intercepts. And y-intercept is located at 0, 5 thirds. And this is negative 1, 0. This is 5, 0. And then 0, 5 thirds is your y-intercept. And it's clear that locate at this one point on each side, sketch the graph. So here's your vertical asymptote. On the left side, you already have 2 points, so you know the graph. On the right side, you have 1 point. You already know the graph, so you don't have to do anything else.